Hello, good evening everyone. Can everyone hear me? Vijay, Ranadeep, Saeed, can everyone hear me?
Yes, sir.
Vaishika?
Good evening, sir.
Okay, so let us start. Today we are going to start with number theory. Okay, that is the first chapter. Up to IOQM, we are going to cover 4 chapters. Okay, mainly 4 chapters from where the questions are asked. Okay, but also we are going to discuss sequence and series. Okay, so first of all, number theory, combinatorics, geometry, and one more, algebra, theory of equations. Yes. We'll be discussing sequence and series also because I've seen questions coming from there. Okay, different types of special series. Okay, meanwhile, I'll be sending some assignments as well. Okay, so I have to solve them. Okay, so can everyone see my screen? Tell me.
Yes, sir.
Okay,
Yes, sir.
let us start. Okay, let us start. Today, our first chapter would be number theory. So let us start, everyone. Okay, where is the. Okay. Okay, so let us start. Okay. Okay, first of all, you should have a slight idea about mathematical induction as well. Okay, principle of mathematical induction. Okay, principle of mathematical induction. So what is mathematical induction? I'll just tell you a brief idea. Okay, some of you already know. Okay, the first thing is that actually this is the first principle. Okay, first principle of mathematical induction, that is, if Pn is a statement, if Pn is a statement, okay, such that, okay, such that P1 is true. Okay, means for n belongs to 1, sorry, n belongs to natural numbers. Pn is a statement for n belongs to natural numbers such that P1 is true. Okay, and Pk plus 1 is true. Pk plus 1 is true for n equal to k plus 1. Okay, then Pn is also true for n equal to k. Then Pn is also true. Okay, just give me 1 minute, everyone. Okay, then Pn is true. Then Pn is true. Okay, for n equal to k. Okay, I'll give you some examples. Okay, where we can apply mathematical induction. Okay, everyone. For example, okay, in our regular classes, I've already discussed like the sum of the first n natural numbers, 1 plus 2 plus 3 plus, okay, dot 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 up to n. What is sum of the first n natural numbers? Tell me, everyone. Yes, Aviraj. N into n plus 1 by 2. Right. So we can also prove this. We can prove this, series using mathematical induction. Okay. Similarly, some of the squares, some of the cubes, we can prove it using mathematical induction. Okay. So I just give you an idea. Like suppose Pn is a statement. Okay. Suppose Pn is a statement such that 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2. Okay, everyone. Okay. Tell me, is P1 true, everyone? Is it true for n equal to 1? Tell me. P1 equal to 1 on the left hand side, and on the right hand side, what are you getting? Are you getting 1? Tell me. Yes, it is equal to 1. Are you people getting? Tell me. Nilanjan, Tahir, everyone is getting? Tell me.
Yes, sir.
Yes, sir.
Okay, P1 is true. Okay. Now suppose Pn is true for n equal to k. Okay. Now you just need to prove that it is true for k plus 1. Okay. Suppose Pn is true for n equal to k. Okay, that is 1 plus 2 plus 3 plus up to dot 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 plus up to k. Okay, is equal to k into k plus 1 by 2. Okay. Suppose it is true for n equal to k. Okay. Now we have to prove it for k plus 1. So what you do is, for k plus 1, what will be the statement? Okay. In rough work, you just understand what will be the statement for k plus 1. Okay. That is 1 plus 2 plus up to k plus 1. This will be equal to k plus 1 into k plus 2 divided by 2. Right, everyone? Tell me. Instead of n equal to k, you just substitute n equal to k plus 1. If it is true for k plus 1, okay, then the statement is true for n equal to k. Okay, everyone. So what I'm going to do is I'm going to add k plus 1 on the left, on both sides. Okay. So 1 plus 2 plus 3 plus dot 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 plus k plus 1. This will be equal to k into k plus 1 by 2. Okay. Plus k plus 1. Okay, everyone. Now over here, when you take 2 as LCM, in the numerator, what are we getting? K into k plus 1 plus 2 into k plus 1. Okay. This will be equal to k plus 1 common. Within brackets, you are going to get k plus 2 divided by 2. See, we are getting the result on the right hand side when you are adding k plus 1. Okay. Hence, it is true for n equal to k plus 1. Hence, Cn is true for n equal to k plus 1. Okay. Means what? See, the whole point of mathematical induction is that Pn, the statement Pn will be true for all n belongs to natural number. If it is true for n equal to k, then it will be true for n equal to k plus 1 as well. So wait, let me think. I have to modify the statement a little bit. If Pn is a statement such that P1 is true and Pk plus 1 is true. Okay. Okay. Tell me, anyone having any doubt? Everyone understood the first principle? Okay, let us do one or two problems. See where the first principle will be helpful to us. Okay. Where will it be helpful to us? Okay. Tell me, has everyone copied? Once you have copied, tell me. Abhijoy, is it clear? Abhijoy, Ramadeep, Venkat, is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Aipshita, Arav, is it clear?
Yes, sir.
Yes, sir.
Okay. Okay, so try this out, everyone. Question number one. Question number one. Prove that 3 to the power 2n minus 8n minus 1 is divisible by 64. Try it out. Prove that 3 to the power 2n minus 8n minus 1 is divisible by 64. Try it out. Once you have done it, send me the whole proof. Okay. Okay, so everyone, should I start? Okay, is it done, anyone? Tell me.
Sir, can I do it like with binomial theorem?
Yes, binomial theorem, try it. If you have done binomial theorem, send it. Is it binomial?
So 3 methods can be done for this question.
Yes. Binomial with induction.
Modular mathematics and
Yes.
also induction.
Congruent modulo also.
Yes, sir.
Done. Wait, I'm coming. Okay, everyone, let us start. Okay. So suppose Pn be a statement. Okay, I think Lanjan has sent. Let's see.
Yes, sir.
Yes, Lanjan, your proof is correct. Everyone pay attention. Suppose Pn is a statement, okay, such that three to the power 2n minus 8n minus 1 is divisible by yes, Opranil, your answer is correct. Is divisible by 64. Okay. Is P1 true? Let us see what is P1. P1 is 3 squared, that is 9. 9 minus 8 minus 1 equal to 0. Yes, it is divisible by 64, right? So P1 is true. So P1 is true. Okay. Once you understand that P1 is true, okay, let us say that Pn is true for n equal to k. Suppose Pn is true for n equal to k. Okay, that is 3 to the power 2k minus 8k minus 1 is divisible by 64. Okay, let us say Pn is true for n equal to k. Okay, that is 3 to the power 2k minus 8k minus 1 is divisible by 64. Okay, then okay, pk plus 1. What is pk plus 1? Pk plus 1 is 3 to the power 2 to k plus 1 minus 8 into k plus 1 minus 1. Okay, let us simplify everyone. Okay, on simplification, what do we get? 3 to the power 2k plus 2 minus 8k minus 8k minus 8 minus 1. Okay, further we can write it as 3 squared, that is 9 into 3 to the power 2k. Okay, 9 into 3 to the power 2k minus 8k minus 9. Okay, everyone, 9 into 3 to the power 2k minus 8k. Okay, I need to prove that this is divisible by 64. Okay, so I have to do some manipulation, okay, such that one part you are getting as 3 to the power 2k minus 8k minus 1, another part you are getting it as multiple of 64. Okay, so what I'm going to do is, can you people understand that in order to take 8k common, okay, can I write it as 9 into अच्छा see, okay, can I write it as 8 into 3 to the power 2k minus 3 to the power 2k, sorry, plus 3 to the power 2k minus 8k, okay, minus 1 minus 8. Okay, now you see 3 to the power 2k minus 8k minus 1. This is divisible by 64, right, everyone? This we have already taken. 3 to the power 2k minus 8k minus 1. This is divisible by 64. Divisible by 64. Okay, next the remaining terms. Remaining terms, when you take 8 common, you are going to get 3 to the power 2k minus 1. Okay, next. Now we have to focus on this one, plus 64, maybe k. Okay, so 8 into, we have got 3 to the power 2k minus 1. If I just prove that this is divisible by 64, my problem, this is divisible by 8, then that means my problem is done. Okay, everyone. the 3 to the power 2k minus 1, can I write it as 9 to the power k minus 1? Tell me everyone. Plus 64, or not k, 64 alpha. Tell me, those who are online, are you people getting? Tell me. I've got 8 into 9 to the power k minus 1 plus 64 alpha. Okay. I have to just prove that 9 to the power k minus 1 is divisible by 8. Achha. So there is a formula, everyone. If you people remember that a to the power n minus b to the power n is equal to a minus b into a to the power n minus 1 plus a to the power n minus 2 into b. Right? I've done it in the in my regular classes. Right? You must have
Yes, sir.
remembered. Plus dot 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 plus ab to the power n minus 2 plus b to the power n minus 1. So this further can be simplified to 8 into 9 into 9 to the power k minus 2 plus 9 to the power k minus 2 plus dot 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 plus 9 plus 1. Okay, plus 64 alpha. Okay, are you people able to see the proof? You see, this is 64 into something, right? Let us say this is 64 into m plus 64 into alpha. Further, you can take 64 common. Okay, so this implies pk plus 1 is divisible by 64. That pk plus 1 is divisible by 64. Okay, this implies pn is for n equal to k. Tell me, are you people getting? For n equal to k. For all n belongs to natural numbers. Tell me. Anyone having any doubt, you can ask me now. Yeah, Viraj, tell me.
How you will from 9 here?
How I got from 9 to the power k minus 1 to 8 into 9 minus 1? This one?
Yes.
Okay. There is a formula. I have discussed it in the regular classes. Okay, with them. Which I have not yet. N is equal to a minus b into a to the power n minus 1 plus a to the power n minus 2 into b plus a to the power n minus 3 into b square plus dot 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 plus ab to the power n minus 2 plus b to the power n minus 1. Okay. So I have used this formula over here. Considering a as 9 and b as 1. So I'll get 9 minus 1 into 9 to the power k minus 1 plus 9 to the power k minus 2 plus dot 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 dot.
And afterwards 9 multiply C2k C multiply C2k.
Which one? This one?
Yes, sir.
9 to the power 9 to 3 to the power 2k. No, which one? Which one?
This one.
I have broken it into two parts. One is 8 into 3 to the power k and another one is 3 to the power 2k.
Oh, now.
Okay, like see 9 can be written as 8 plus 1. And why did I do it? Because I know that 3 to the power 2k minus 8k minus 1 is divisible by 60. Is it clear? Okay. Tell me, is it clear? Arav, have you understood? Arav or Vijay? Did you people
Yes, sir.
understand?
Yes, sir.
Ramadeep, Venkat, are
Yes,
you
sir.
getting? Okay. Next. Okay. See, not only in number theory, but also mathematical induction is sometimes helpful in writing the proofs for inequalities. Okay, everyone. Let us do one problem from inequality. Okay, how it can be helpful to us in inequalities. Okay, everyone, pay attention. Okay. So question number 2. Prove that n factorial. You people know the meaning of n factorial? If you don't know, tell me. I'll explain. N factorial is greater than 2 to the power n. For all n belongs to, for all natural numbers n greater than or equal to 4. All natural numbers n greater than or equal to 4. Okay. Now what is n factorial? N factorial is equal to 1 into 2 into 3 into up to dot 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 up to n. Okay, this is means product of all the natural numbers from 1 to n is n factorial.
What?
N.
Not not
Okay, should I start, everyone? Tell me. Over here, you have to prove that n factorial is greater than 2n, 2 to the power n. Okay, let me see. So Ahir has sent. Okay, Raudip has sent. Let's see. So over here, you cannot start with n equal to 1. You have to start with n equal to 4. Okay, because n should be greater than or equal to 4. Yes, Ahir, your proof is correct. Yes, Venkat, your proof is correct. So this one is easy only, everyone. Yes, Raudip, your proof is correct. Okay, this one is easy. Let us start. Okay, over here, pay attention. I want to prove that n factorial is greater than 2 to the power n, or n greater than or equal to 4. Okay, suppose Pn is a statement. Suppose P is a statement. Such that, okay, n factorial is greater than 2 to the power n, for n greater than or equal to 4. Is P4 true? What is P4? P4 is 4 factorial. P4 is 4 factorial, which is 24. And what is 2 to the power 4, everyone? 2 to the power 4 is 16. Okay, 24 is greater than or equal to 16. Okay, P4 is true. So let Pn be true. Pn be true for n equal to k. Okay. So we have to find out pk plus 1. Okay. So what is Pn? Pn is 1 into 2 into 3 into 4 into dot 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 up to n. Okay, this is greater than or equal to 2 to the power k. 2 to the power n. Okay. Let us take k. Okay, Pn is true for n equal to k. This is already given to us. Okay. So in order to prove for pk plus 1, on the left hand side, you should have k plus 1 whole factorial. Let's multiply by k plus 1 on both sides. This implies 1 into 2 into 3 into dot 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 into k plus 1. This must be greater than or equal to 2 to the power k into k plus 1. Right, everyone. Now, everyone, can I say k plus 1 is greater than 2? Tell me, everyone. Tell me. Aipshita, Vijay, Arav, can I say this? K plus 1 is greater than 2? Strictly greater than 2? Okay.
Yes, sir.
So I can write k plus 1 as 2 over here. This implies k plus 1 whole factorial must be greater than 2 to the power k into 2. This implies it will be greater than or equal to 2 to the power k plus 1. Hence, tell me, is it clear to everyone? If you didn't understand, you can ask me. I'll explain. Okay, so this was all about first principle. Okay, everyone. This was all about first principle of mathematical induction. Okay, but there are some more. There are some more. Okay. There is the second principle also. Okay, but I'm not going to do a problem on second principle of mathematical induction. Okay. Second principle of mathematical induction. Okay. What does it says that if P1 is true, if Pn be a statement, if Pn be a statement, such that P1, P2, P3, dot up to Pk minus 1 is true, are true. Okay. Then Pk is also true. Okay. This is the second principle. Let me just check. Okay. So basically P1 should also be true. Okay, P2 should also be true. P3 should also be true. Pk minus 1 should also be true. Okay. Pk should also be true. Then Pk is also true. Okay. This can also be modified as, pay attention, this can also be modified as that Pn plus 1 is true. Pn plus 2 is true. 3 is true. Okay, Pk is true. Okay. Then we can say Pk plus 1 is also true. Acha, Pk plus Pn is also true for, or Pn is also true for n belongs to natural numbers. Okay. Next. Okay, there are few formulas you people should remember. Okay. So first of all, let us understand divisibility test of integers. Okay, properties of divisibility. Properties of divisibility. Okay. Number 1. If I say A divides B and B divides C, and this also implies that A divides C. Okay, means A divides B, B divides C, then A also divides C. Number 2. If A divides B and A divides C, then this implies A also divides B plus minus C. Okay, it will divide B plus C also, it will divide B minus C as well. Okay, number 3.
So why not say B minus B
B minus B.
plus minus B of B? B can be also divided, so minus also plus also.
I have written B plus C also, B minus C as well.
Both the same.
It will divide B plus C, it will divide B minus C. I have written in the same statement. Okay. Next, if A divides B and A divides B plus C, and this also implies that A will divide C. Okay. It cannot happen that A does not divide C. If A divides B, A divides B plus C, so A also divides C. Okay, number 4. If A divides B and A divides C, then this also implies A divides KB plus minus LC. Okay, it also divides KB plus minus LC. Okay, next. Number 5. If A divides B and B divides A, what conditions? This diversity test is competitive. A is also dividing B, B is also dividing B. A. In what case it will be true? Tell me, everyone. What do you think?
They're equal.
When their absolute values are equal, that is A equal to plus minus B. Right, A can be equal to B, A can be equal to minus B as well. Number 6. So, A divides B. Okay, A divides B implies B equal to 0 or mod of A is less than or equal to mod of B. Remember, sometimes this rule is also used in inequalities. Okay, sometimes questions inequalities, this rule can also be used. Okay, mod of A, they will give you just A divides B. Okay, you have to use inequality. Mod of A is less than or equal to mod of B. Okay, or in particular, if it is specifically given that A is greater than 0 and B is greater than 0, okay, then A will be strictly less than B. Okay. Tell me, Abhijay, are you getting?
Yes, sir.
Next.
Can you, after this, can you give 2 of 4 and 6 for these 4 and number 4 and 6 that A is equal to this one, 4 and 6.
What, 4 and 6 couldn't use? Proof. Proof like I'll tell you the numbers only. Let's see. 2 divides 4,
Yes.
2 divides 8.
Yes.
Can I say 2 divides 4 into 5 plus minus
Oh, understood.
2 into, okay. They are very simple. You just take with numbers, you will get it. Okay. Next. If A divides B, okay, everyone. If A divides B, this implies A also divides BC for some C belongs to integers. Okay, everyone. For some C belongs to integers. Okay. Lastly, number 8. A divides B if and only if MA also divides MB, where M is not equal to 0. Okay, M should not be equal to 0. Okay, next. Okay, there are 2 formulas which you people should remember. One is x to the power to the power n will be equal to x plus y into x power n minus 1 plus x power n minus 2 into y plus x power n minus 3 into y square plus minus plus then minus then plus dot. Lastly, it will be plus y to the power n minus 1. Let us see, everyone. Alternately, it is positive, negative, positive, negative, positive, negative. It goes on like this. Okay. Can anyone tell me why the last term should be positive? Last term could be negative also. Raise your hand. Tell me why the last term is positive. In last term, or if I am wrong, then also explain. Yes, Ronaldip, tell me.
So the last term has to be positive because y to the power n is positive, right?
y to the power n is positive? Couldn't understand. No. Can you give me a reason? Like, see, it is going positive in the second factor. You have once you have positive, another time
Sir,
negative.
n is odd.
Positive. Yes, because n is odd. If n is odd, n minus 1 is even. Are you people getting? And if n minus 1 is even, then y should begin with a positive sign. Okay, next, x power n minus y to the power n. X power n minus y to the power n will be equal to x minus y into x power n minus 1 plus x power n minus 2 into y plus x power n minus 3 into y square plus dot plus y to the power n minus 1. Tell me, are you people getting? Yes or no? There's anyone having any doubt, you can ask me. Tell me. Tell me, Trishita, are you getting? Trishita, Venkat, are you people getting?
Yes.
Oh, okay. So why I have written these two first? Because you see, this implies x power n plus y to the power n is divisible by. Acha, everyone, wait. I didn't write the conditions. There are certain conditions when these formulas are valid. The first one is valid for all n belongs to odd natural numbers. Okay, everyone. Or you can say for all n equal to 2k minus 1. For k belongs to natural numbers. Okay. Next one is valid for all n belongs to natural numbers. Okay. So first, for the first formula, you cannot expand it with x square plus y square or x power 4 plus y to the power 4. Okay, I can show you the proof as well. Okay, everyone remembers remainder and factor theorem? Tell me, everyone.
Yes, sir.
Everyone remembers remainder and factor theorem? Okay, let's see the proof. Okay, for the first formula, factor theorem. Okay, suppose f of x equal to x to the power n plus y to the power n. Okay, everyone. What I'm going to do is I'm going to substitute f of minus y. F of minus y is equal to minus y whole to the power n plus y to the power n. Now this expression will be equal to 0 if and only if n is odd.
Sorry, odd.
Odd. Right, everyone. If n is odd, minus y to the power n will become minus y to the power n. Minus y to the power n plus y to the power n will get cancelled. Then only you are going to get 0. Are you getting? So this implies x plus y is a factor of f of x. When n is, if n is even, it will not happen. Okay. If there's anyone having any doubt, tell me. Next. So from these formulas only, okay, from these two formulas only, we have x power n plus 1. X power n plus 1 is x plus 1 into x power n minus 1 minus x power n minus 2 plus x power n minus 3 dot plus 1. For n is odd. For n equal to 2. For n is odd natural numbers. Next. And so x power n minus 1 will be equal to x minus 1 into x power n minus 1 plus x power n minus 2 plus x power n minus 3 plus dot plus x plus 1. Okay. Next. Okay, next. Okay. Notation of n factorial. So what is n factorial? N factorial is equal to n into n minus 1 into n minus 2 into n minus 3 up to dot 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 into 3 into 2 into 1. The product of all the natural numbers from 1 to n. Natural numbers from 1 to n. Okay, for example, 5 factorial is equal to 120, 4 factorial is equal to 24, 3 factorial is equal to 6, okay, and so on and so forth. Okay, similarly, n factorial can also be written as n into n minus 1 whole factorial. Okay, everyone. N factorial can also be written as n into n minus 1 whole factorial. Next, number 3. So what is the value of 0 factorial? 0 factorial is equal to 1. Okay. How 0 factorial is equal to 1? Pay attention. We know that n into n minus 1 whole factorial is equal to n factorial, right? What you do is you put n equal to 1. What do we get? 1 into 1 minus 1 whole factorial is equal to 1 factorial. This implies 0 factorial is equal to 1. Is it clear? Tell me, Avraj, are you getting? Okay. Next, number 4. Okay, there is something called NCR. Okay, currently I'm going to just write down the expression. The original proof and the exact meaning of NCR I'll be discussing in PNC. Okay, when I discuss PNC, okay, then I'll discuss NCR. NCR is factorial divided by R factorial into n minus R factorial. Okay, NCR is equal to n factorial divided by R factorial into n minus R factorial. Okay. So the literal meaning of NCR is the number of ways to select n things taken R at a time. Or number of ways to select R things out of n things. Okay. Like for example, if I ask you to select number of ways to select 3 people out of A, B, C and D. This can be done in 4C3 ways, right? 4C3 will be equal to 4 factorial divided by 3 factorial into 4 minus 3 whole. Okay. Which is equal to 4. Remember. Okay. Next. Similarly, we have NPR as well. NPR will be equal to n factorial divided by n minus R factorial. Okay. What is the meaning of NPR? NPR means number of ways to arrange n things taken R at a time. Okay. Next. I'm going to discuss division algorithm. Okay, everyone. Okay, these are some basic notions which you should remember. Okay. Next, everyone knows what is division algorithm. I don't think I need to explain much. Okay. Division algorithm. That is dividend is equal to divisor into quotient plus remainder. Okay. Dividend is equal to divisor into quotient plus remainder. Okay, that is if A equal to PQ, if that is A equal to BQ plus R, where R should lie between 0 and B. Mod of B. Okay, everyone. I have defined it for negative integers as well. R should always lie between 0 and B. Okay. Next. Let's ask everyone, what is the application of division algorithm? Okay. For example, any number, any natural number, when you divide it by, any number when divided by 3 can give us what are the possible remainders, everyone, when you divide it by 3? When you divide any number by 3, what are the possible remainders?
2 and 1.
2 and 1.
0,
as well.
1, 2.
Can give 0, 1 or 2 as the remainders, right? 2 as remainder. Okay. So can I say, everyone, so any natural numbers, so any number n can be written in the form of 3k or 3k plus 1 or 3k plus 2. Okay, everyone. What are the elements in 3k? A 3k. What are the elements in 3k? Dot 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 minus 6, minus 3, 0, 3, 6, 9 dot 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 dot. These are the integers which are of the form 3k. Right, everyone. These are the integers which are of the form 3k. Like for 3k plus 1, what are the elements that are of the form 3k plus 1? Tell me. Dot 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 minus 5, minus 2, 1, 4, 7 dot 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 dot. Okay, these are of the form 3k plus 1. That is, when you divide them by 3, the remainder is 1. Okay, next. A 3k plus 2. What are the numbers which are of the form 3k plus 2? Okay, dot 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 dot. Okay, dot 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 minus. Okay, minus 4, minus 1, 2, 5, 8 dot 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 dot. Okay, these are the numbers which when divided by 3 leaves us the remainder 2. Okay, so everyone, if I ask you, what is the intersection of these three sets? What is the intersection of these three sets? There is no intersection, right, everyone? It's a null set. But if I take the union of all the three sets, what will I get? Tell me, everyone. If I take the union of all three sets, it will be the set of integers. Right, it will be the set of integers. Next, there is one theorem, everyone. Okay, there is one theorem. Okay, product of any r consecutive integers. Product of any r consecutive integers. Consecutive integers is divisible by r factorial. Okay, everyone. Product of any r consecutive integers is divisible by r factorial. Let us see the proof. So, everyone, let us take any r consecutive integers. Let p is equal to m into m plus 1 into m plus 2 into m plus 3 dot 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 dot. What will be the rth integer? Rth integer will be equal to m plus r minus 1, right? So let us start with m plus 1. Okay, it would be easier for you people to understand. Okay, I'm going to take r consecutive integers, m plus 1, m plus 2, m plus 3 dot 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 up to m plus r. Okay, this is the r. These are r consecutive integers. Okay, everyone. Okay. Okay, so over here, let us multiply numbers. Okay. In order to complete the factorial. Now, whenever you are talking about n factorial always starts with 1, right, everyone? If you take the factorial of any number, it always starts with 1. But over here, is it starting with 1? No. It is starting with m plus 1. Okay. So what I'm going to do is I'm going to multiply certain terms so that it becomes a factorial. Okay, everyone. So I'm going to multiply m into m minus 1, pay attention, into m minus 2 up to dot 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 into 3 into 2 into 1. Okay, everyone. See, I've multiplied by m into m minus 1 into m minus 2 up to 3 into 2 into 1. So everyone, this whole thing, what does it becomes? Tell me. This whole thing, what does it becomes? Tell me, everyone. This is 1 into 2 into 3 into dot 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 m minus 2 into m minus 1 into m plus 1, m plus 2 up to m plus r.
M plus r factorial.
M plus r whole factorial. Now since I have divided, I have multiplied by m into m minus 1 up to m minus 2 up to m plus up to m. I'll divide it by the same thing, 1 into 2 into 3 up to dot 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 up to m. Okay. So see, the numerator becomes m plus r whole factorial. Okay, everyone. The numerator becomes m plus r whole factorial. And what is the denominator, everyone? The denominator is m
M
factorial.
factorial.
Tell me, anyone having any doubt, you can ask me. Okay. So everyone, yes, tell me. What's the doubt? Because if you talk about any factorial, okay, like if you talk about x factorial, it is 1 into 2 into 3 into up to x, right? So in the numerator, what did I write? Tell me, Aviraj. I have written 1, 2, 3, 4. I have written all the consecutive integers up to m plus r, na? That will become m plus r or factorial. Okay. Since I have multiplied by 1 into 2 into 3 up to m, so I have to divide by the same thing, m factorial. Understood? Since I have multiplied by m factorial in the numerator, this purple expression is m factorial only, right? So since I have multiplied by m factorial in the numerator, I have to divide by the same thing, right? So I have divided by m factorial as well. Okay. Next, over here, just now we have done the expression for NCR, right? Just now I have defined NCR. NCR is n factorial divided by r factorial into n minus r whole factorial, right? Tell me. Okay. So over here, m plus r whole factorial divided by m factorial. If I multiply and divide by r factorial, okay. See, this whole thing can be written as m plus r whole factorial divided by m plus r minus r whole factorial multiplied by r factorial. So see, this whole expression becomes m plus r cr. Tell me, are people getting? Multiplied by r factorial. Now since m plus rcr belongs to integers, can I say that this is divisible by r factorial? Tell me. This implies the product is divisible by r factorial. Tell me, anyone having any doubt? Tell me, Aviraj, is it clear? Aviraj, have you understood? Tell me. Over here, Arav, Oipshita, Avijay, Ahid, is it clear? Nilanjan,
Yes, sir.
Rajit,
Yes,
Prishita,
sir.
Venkat, is it clear?
Yes, sir.
Venkat, are you getting? Okay. Note everyone. Okay. Product of three consecutive integers. Just like that, we can say product of three consecutive integers. Product of three consecutive integers is always divisible by. Is always divisible by 3 factorial. That is 6. You can check it. You can take any three consecutive integers. You'll always find that it is divisible by 3 factorial. Okay. Next. Okay, so let us do one problem based on this. Okay. Prove that, question number 1. Question number 3. Prove that r into r square minus 1 into 3r plus 2 is divisible by 24. Solve. Done? No. Is it done, anyone? Those who are online, tell me.
I'm sending.
Send. me check. Okay, so I think Olpshita has sent it. Let's see. Yes, Olpshita, you are absolutely correct. Okay, Venkat, you have to break 3R plus 2. Okay, until unless you break it, you won't be able to, identify the pattern. You have to break it somehow. Okay, Radhip has sent it. Let's see. Okay, Radhip, you are correct only, but okay, I understood. But this could be done in some other way also.
Okay, sir.
See, Radhip, over here. Achha, okay, I understood. I understood your proof. Okay. So everyone pay attention. Over here, in this 3R plus 2, you have to do some manipulation, okay? Because R into R square minus 1, over there you have got 3 consecutive integers, so pay attention everyone. R into R square minus 1. Can I write it as R minus 1 into R plus 1. And over here we have got 3R plus 2. 3R plus 2, can I write it as plus 1 minus 1? Tell me everyone. Means can I write it as 3R plus 3 minus 1? Tell me. Are you people getting? Yes or no? CR plus. Yes, Arav, tell me.
No, sir, I got it.
Okay. Wait, I think I have to break it in some other way. 3R plus. Okay, just right. Wait. So can I break it like this? 3R 3 into R plus 2 minus 4. Tell me everyone. Can I break it like this? So that I'll get R plus 2 over here. Pay attention everyone. I need only consecutive integers. R minus 1, R plus 1. Other one will be R plus 2. Tell me, are you people getting? Yes or no? Or you could have also broken it like this: 3 into r minus 2 plus 4. So everyone, this will become, pay attention, this will become, when you open the brackets, this will become 3 into r minus 2 into r minus 1 into r plus 1, right, plus 4 into r minus 1 into r plus 1. Now everyone, this r minus 2 into r minus 1 into r plus 1 into r plus 1, can I say it is divisible by 4 factorial? Tell me everyone. This is divisible by 4 factorial, and 4 factorial into 3. I mean, this whole thing is divisible by 24. Next, similarly, r minus 1 into r plus 1 is divisible by 3 factorial. Tell me everyone. When you multiply it by 4, this will be divisible by 4 factorial. Right, tell me, Avraj, are you getting? Okay, Venkat, have you understood now? Venkat, Trishita?
Yes.
Okay. Arav, is it clear? Therefore, the
Yes,
whole
sir.
expression is divisible by 24. Niranjan, is it clear?
Yes, sir.
Okay.
Sir,
Next.
we could have
Yes,
also broken 3r plus 2 into 2r plus r plus 2.
to r plus 2.
Yes,
Okay,
sir.
how? So that would be cool. Let's see. So I've got r minus 1 into r plus 1, and this can be written as 2r plus 2. Then,
So then we can break it like r minus 1 into r plus 2, like we will get 4 consecutive, and then we can analyze odd and even.
oh, acha, yes, I understood. I understood. But this way it is better. You see, it is directly coming in 2 lines. Understood.
Yes, sir.
Without checking for any. Okay. Next, everyone. Till now, anyone having any doubt, you can ask me. Okay, I think
Sir, could you
Niranjan.
check my method once? Could you check my method
Yes,
once?
I'm checking your method. Oh, you have taken as odd
Yes,
and
I
even.
did by
Yes, this is the
parity.
method. Yes. This method, he also has told this method. So yes, this method is correct. It can be done, no problem.
Thank you, sir.
Yes. Okay. Next, let us continue, everyone. Okay. Next, we are moving on to factors and multiples. Okay, everyone. Let us understand what are factors, what are multiples. Okay, HCF LCM factors, everyone. So when we say A is a factor of B, okay, A is a factor of B. Whenever we say A is a factor of B, if there exists a relation such that A multiplied by N is equal to B. For example, you see 2 into 4 is equal to 8. This implies 2 is a factor of 8. Avraj, did you understand the previous one? Tell me. Why? What happened? Which one you didn't understand? Tell me.
These factors are very much unknown, sir.
Which factor is unknown?
Like 4 factors, 2 factors are known.
4 factorial, just now I told you, no? It is 24.
Yes.
3 factorial is 6.
But how they are getting, I don't know.
This is the product of 4 consecutive integers. They are consecutive or not? Tell me. R minus 2, R minus 1, R and R plus 1, they are consecutive integers. So it is like 4 factorial. R minus 1, R plus 1, they are 3 consecutive integers. So it is divisible by 3 factorial. Right? Tell me. Next. 2 is a factor of 8. Okay, next. 1 is a factor of all numbers. 1 is a factor of all the numbers. Okay, everyone. 1 is a factor of all the numbers. Next. Factor of a number. Okay, a factor of a number cannot be greater than the number itself. Cannot be greater than the number itself. Okay. For example, what are the factors of 8? Factors of 8 are 1, 2, 4 and 8. Okay. Next. Number of factors of a number is always finite. Okay, everyone. Number of factors of a number is always finite. Okay. Is always finite. Like see 8. Okay, the factors of 8 are 1 to 4 and 8. Can it be more than 1 to 4? I mean, more than 4. Okay. Are always finite. Okay. Next. Multiples. Multiples. So A is a multiple of B. A is a multiple. A is a multiple of B. When can we say A is a multiple of B? If there exists a relation. If there exists a relation. If there exists a relation such that B multiplied by N is equal to A. Okay, everyone. For example, you see 6 multiplied by 2 is equal to 12. So I can say that 12 is a multiple of 6. Okay, everyone. If you people have any doubt, you ask me, I'll explain. 12 is a multiple of 6. Okay. That's the smallest multiple of a number. The smallest multiple of a number is the number of a number is the number itself. Okay, the number itself. Okay, next. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Okay. Like every natural number, or you can say every positive integer. Every positive integer can be written as a product. Can be written as a product of primes. If it is composite. So if a number is composite, okay, it can be written as a product of primes, right? You people must have done it in class 7, 8, okay, taking prime factorization. Okay, that is what fundamental theorem of arithmetic is. For example, 12. 12 can be written as 12, 2 square into 3. Okay, for the generalized form. Generalized form. Okay, n can be written as p1 to the power alpha 1 into p2 to the power alpha 2 into p3 to the power alpha 3 dot up to pk to the power alpha k. Okay, where p1, p2, pk are prime numbers, where p1, p2 up to pk are prime numbers. Okay, p1, p2, pk are prime numbers. Next, let us talk about number of factors of a number. Okay, number of factors of a number. So everyone, if I say n equal to p1 to the power alpha 1 into p2 to the power alpha 2 up to pk to the power alpha k. Okay, then the number of factors of n will be equal to alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 up to alpha k plus 1. Okay, this is the number of factors of n. Tell me. Arav, Abhijoy, Venkat, are people getting? Tell me.
Yes, sir.
Yes, sir.
Okay. Nilanjan, Ramadeep, Ahir, Tushita,
Yes,
are
sir.
people getting?
Yes,
Venkat?
sir.
Okay.
Yes, sir.
Next. So the number of factors of n will be equal to alpha 1 plus 1 into alpha 2 plus 1 up to alpha k plus 1. Okay, everyone? Like for example, okay, I'll first of all give you an example. Okay, then I'll give the proof as well. Okay, like for example, you see factors of 12. What are the factors of 12, everyone? Factors of 12 is equal to 2 square and 3. 2 square into 3, right? Okay. So, so we can say that the number of factors of 12 will be equal to 2 plus 1 into 1 plus 1, which will give us how much? 6. Okay. Let us write those 6 factors. Okay, everyone. Those 6 factors are factors of 12 are what are those 6 factors? 1, 2, 3, then 6. Am I missing anything?
Sir,
Or four,
Oh wait,
four, four.
4 I am missing. 4, 6, 12. Okay, so there are 6 factors. Okay. Next, let us see the proof. Okay. Just give me 1 minute, everyone. Okay, factors of 12 are 1, 2, 3, 4, 6, 12. Okay, so let us see the proof. Let us see the proof. Okay. So let us say, suppose n equal to p1 to the power alpha 1 into p2 to the power alpha 2 into p3 to the power alpha 3 up to pk to the power alpha k. Okay, everyone. Let us say that this is n. Okay, everyone. Where p1, p2 up to pk are prime numbers. Okay. Where p1, p2 up to pk are prime numbers. Okay. Now, everyone, if I want to write down the factors of p1 to the power alpha 1. Okay. See, everyone, how to analyze this? How to write down the factors of p1 to the power alpha 1. Okay. So let us talk about 2 cube. Okay. For example, 2 cube. Okay, everyone. What are the factors of 2 cube, everyone? Raise your hand. Tell me. What are the factors of 2 cube? Tell me. What are the factors of 2 cube?
Sir, 1, 2, 4, 8.
Wait, just raise your hand, then I'll let
Oh.
you speak. Yes, Radhik, tell me.
Yes, sir. 1248.
1, 2, 4, 8. How are we getting? 2 to the power 0, 2 to the power 1, 2 square, 2 cube, right? Tell me. 2 to the power 0, 2 to the power 1, 2 square, 2 cube. Okay, these are the factors of it. Okay, P1 to the power alpha 1. So everyone, okay, so factors of P1 to the power alpha 1 will be equal to P1 to the power 0, P1 to P1 square, P1 cube, to P1 to the power alpha 1. Right. Total, how many factors I have written? Tell me everyone. I have written alpha 1 plus 1. Right, tell me alpha 1 plus 1 factors. Right, tell me everyone. The number of factors I have written is alpha 1 plus 1. You see, that is from 0, 1, 2, 3, 4 up to alpha 1. Okay, I have written alpha 1 plus 1. Right, Abhijay, are you getting? Abhijay, Venkat, Tishita, are
Yes,
people
sir.
getting? Dilanjan, Radhi?
Yes.
Okay.
Yes, sir.
Anyone having any doubt? Abhishita, is it clear? Tell me.
Yes, sir.
Okay. Similarly, factors of P2 to the power alpha 2 will become alpha 2 plus 1. Right, Aviraj? Okay, then alpha 3 plus 1. Okay, so are you getting how we are getting the result? Tell me alpha 1 plus 1, alpha 2 plus 1. Okay, hence the result follows. Okay. Next. HCF and LCM. Okay, HCF and LCM. Highest common factors and least common multiple. Okay, number 1. Multiples of n, okay, will be equal to n1, n2, n3, up to infinity. Multiples of L will be equal to L1, L2, L3, up to infinity. Okay, these are the multiples of n, these are the multiples of L. Okay, so there should be some common multiples of both the numbers. Okay, suppose the LCM of and or not LCM, multiples of n comma L will be equal to P1 comma P2 comma P3 up to infinity, such that P1 is less than P2 is less than P3 up to go on. So over here, what is the LCM, everyone? Over here, what is the LCM? Can anyone tell me? Suppose multiples of n comma L are P1, P2, P3 up to infinity, such that P1 is less than P2 is less than P3 up to infinity will be the LCM. We are talking about least common P1, right? LCM will be equal to P1. Okay. Next, number 2. HCF of all the common factors. HCF of all the common factors is the highest number that divides HCF of all the that divides HCF of all the common factors a highest number that divides the given numbers. Okay. Next, properties of GCD. Properties of GCD, greatest common divisor. Okay, so what are the properties of GCD? Number 1, GCD of A comma B must be greater than or equal to 1. Okay, the greatest common divisor should always be greater than or equal to 1. Huh? HCF or GCD, they both are same. It is noted by first brackets.
Sir, can you scroll a bit up?
Yes.
Thanks.
HCF or GCD, they both are same. Okay. Done, Randeep?
Yes, sir, almost. Yes, sir, I'm done.
Okay. Okay, next. HCF of A comma B is also equal to HCF of mod of A comma mod of B. Okay, everyone. Because HCF cannot be negative. Okay, for example, if I talk about HCF of minus 18 comma 24, then this will be HCF of mod of minus 18 comma mod of 24, which will be equal to 6. Okay, next, number 3. Can someone tell me what is the HCF of A comma 0? Tell me. 0. Why? Will 0 divide both? So, what is the HCF of A comma 0? Anyone tell me? Mod A. Yes. Already answer is given. Mod A. Remember, A should not be equal to 0. Number 4. HCF of A comma B is equal to HCF of B comma A. Remember. Okay. Next. Number 5. For any non-zero M belongs to integers. Okay. GCD of MA comma MB must be equal to mod of M into GCD of A and B. Okay, for example, if I talk about GCD of 36 and 24, this will be equal to 12 into GCD of 3 comma 2, which is equal to 12. Number 6. If GCD of A comma B is equal to G, then GCD of A by G comma B by G will be equal to 1. Okay. Like for example, GCD of 36 and 24 is equal to 1. Sorry, 12. So GCD of 36 by 12 comma 24 by 12, you see it will be equal to 1 only. Next, number 7. If GCD of A comma B is equal to 1 and GCD of A comma C is equal to 1, then this implies GCD of A comma BC will also be equal to 1. Okay, for example, you see GCD of 2 comma 3 is equal to 1 and GCD of 2 comma 5 is equal to 1. This implies GCD of 2 comma 15 is equal to 1. Okay. Next. Number 8. If GCD of A comma B is equal to G, then there exists two integers x and y. Two integers x and y such that ax plus by is equal to g. Okay, everyone. For example, you see GCD of 2 comma 5 is equal to 1. Okay. Then can you find out two integers such that 2x plus 5y is equal to 1? Tell me. Can anyone tell me two integers such that 2x plus 5y is equal to 1? Yes, raise your hand. Tell me. Yes, Ramadip, tell me.
So x is 3 and y is -1.
X is 3 and y is minus 1. Correct. Okay. Next. Number 9. LCM into HCF is equal to product of two numbers. You people know it already, right? Product of two numbers. LCM into HCF is equal to product of two numbers. Number 10. This is known as Bezout's identity. Everyone knows. I mean, those who were there with me since 9, 10. Okay, this is Bezout's identity. That is, if GCD of A and B is equal to 1, okay, everyone, then there exists some m comma n belongs to integers such that am plus bn is equal to 1. Okay. But I'm proving Bezout's identity. Okay, everyone. Basically, I'm going to prove part 8. Okay. 10, you can prove it by yourself. If you understand the proof of 8, you can understand the proof of 10 as well. See. That is, suppose D is equal to GCD of A and B. Okay, everyone. Suppose D is equal to GCD of A and B. This implies D divides A and D divides B. Right, everyone, tell me. D divides A and D also divides B. So can I say, everyone, D divides AX and D also divides BY? I can say this. So what does it imply? It implies that D divides AX plus BY. Okay. If D divides AX plus BY, I can say that AX plus BY is equal to KD for some K belongs to integers. And what is the least positive value of K? What is the least positive? It is valid for all values of K, right? What is the least positive value of K? Of K will be equal to 1, right, everyone?
Yes, sir.
This implies AX plus BY is equal to T. Okay, hence proved. Okay, let us do some problems, everyone. Question number, what is the question number, everyone? The last question we did, number 3. So this is question number 4, 5 and 6 coming up on your screen. Question number 4. How many numbers are there from 200 to 600 that are divisible by 4, 5 and 6? That are divisible by 4, 5 and 6. Question number 5. If n equal to if n equal to 12 cube into 3 to the power 4 into 5 square, find number 1. Number of factors of n. Number 2. Number of odd factors of n. Number 3. Number of even factors of n. Number of 4. Number of ways n can be written. N can be written as a product of two numbers. Solve everyone, solve. Once you have done it, keep sending our answers. Okay, Trishita, check the first one. Yes, Nanjan 5 part 1 is correct. Yes, here number 4 is correct. Abhipshita, part 1, 2 and 3 are correct of 5. Ramadip, 4 is correct. 5 part 1 is also correct. Observe, 4 is correct. Tishita, 5 part 1 is correct. Venkat, 5 part 1 is correct. Ramadip, 5 part 2 and 3 are correct. Yes. Aviraj, anything is done? No.
The doing, sir.
Which one? 4.
First 4 to 1.
4 or 5? Which one?
4.
4. Solve. Yes, Ramadip, part 4 is correct. Yes, Venkat, part 2 is correct. Yes, Abhijay, your answers are correct. Yes. Venkat, others are correct. I mean 3 and 4. Yes. Niranjan, your answers are correct. Tishita, now 5 part 1, 2, they are correct. Yes, Ahir, are you solving?
Yes, sir.
Sam. Yes, Ahir 5 part 1 is correct. Tishita 5 part 3 is correct. Yes. Raj, is it done? Which one is done?
4, sir. Is it this?
No. Achha, how many numbers are there between 200 and 600 which are divisible by 4, 5 and 6? Okay. From means both 200 and 600 included. 4, 5 and 6. So Viraj, if a number is divisible by all three, 4, 5 and 6, that means the number should be divisible by the LCM of their, right or not? What is the LCM of 4, 5 and 6? Tell me, Aviraj.
4, 5, 4.
What is the LCM? What is the LCM? Tell me. 4, 5 and 6. How much? How much are you saying?
60.
Ha, 60. Okay. Okay. LCM of 4, 5 and 6 is 60. Okay. Next. So over here, we need to find out those numbers which are divisible by 4, 5 and 6. I mean 60 between 200 and 600. So what will be the first number? 240. Right. So what are those numbers? You can manually count it. 240, 300, 360, 420, 480, 540, and 600. How many numbers are there? 7. Done. And it's very simple. Yes, here all your answers are correct. So those who have done pipe part 1, 2, 3 and 4, for them I have another question. Find the number of ways in which n can be written as a product of two numbers. Product of two numbers that are relatively prime to each other. That are relatively prime to each other. Okay. That are relatively prime to each other. Okay. Solve. Okay, so Aviraj, I'm solving part 1. Okay, 5 part 1. Number of factors of n. So I have given the formula, right? Number of factors of n. What is the formula? Tell me, Aviraj. Formula was 1 second. Quickly, tell me.
The formula was
Alpha, you didn't write it. You didn't write the formula, number of factors of n. Under fundamental theorem of arithmetic. What was the formula?
Yes, sir. Number of factors n is equal to P1 alpha plus P2 alpha the
Multiplied by P2 or alpha 1 plus 1 into alpha 2 plus 1 up to alpha n plus 1. So first of all, we have to prime factorize it, right? 12 cube means what? 2 square into 3 whole cube multiplied by 3 to the power 4 multiplied by 5 square. This will be equal to 2 to the power 6 multiplied by 3 cube multiplied by 3 to the power 4 multiplied by 5 square. This will be how much? 2 to the power 6 into 3 to the power 7 multiplied by 5 square. Right. Okay. So the number of ways will be equal to 6 plus 1 into 7 plus 1 into 2 plus 1. Right. That gives us how much?
7 plus 7 multiply 8 multiply
7 into 8, 56 into 3 is 168, right? Tell me. Number 2, we need to find out the number of odd factors. So, Aviraj, tell me, if I want to find out the number of odd factors, of n, okay, you see, over here, from here, if I take anything from 2 to the power 6, means if I take any element from 2 to the power 6, the factor will become even, right?
Yes.
So you don't take anything from 2 to the power 6. What is remaining? 3 to the power 7 into 5 square. So it will be 7 plus 1 into 2 plus 1. Right? Tell me. This will give us how much? 24. Number 3. So Raj, the total number of factors is 168. Total number of odd factors is 24.
Even so even so 6 plus 1 is 7.
Number of even factors will be equal to, from the total number of factors, we have to subtract the number of odd factors. 144. Is it clear, Aviraj? Tell me.
That will not go to 2 to the 6 plus 1.
But that in that way you are only taking 2. But it can happen, na? 2 into 3 is also an even factor. 2 into 3 to the power 1 is also an even factor. 2 to the power 4 into 3 to the power 6 is also an even factor. We are not considering those numbers. If you consider those numbers as well, right? Next. Because a factor of a number can either be odd or even. Okay. So from the total number of factors, you subtract the number of odd factors, you'll get the number of even factors. Right. Number 4. That is the number of ways in which n can be written as the product of these numbers. Okay, product of these numbers. Okay, so one way to write the numbers are is 1 into 2 to the power 6 into 3 to the power 7 into 5 square. This is one way to write it, right? 1 into 2 to the power 6 into 3 to the power 7 into 5 square. This is one way to write the total number of odd factors. Okay, total number of ways in which we can write it as the product of two numbers. Next, another way to write it as 2 into 2 to the power 5 into 3 to the power 7 into 5 square. Right, tell me. Another way to write it as 3 into 2 to the power 6 into 3 to the power 6 into 5 square. Another way to write it as 4 into 2 to the power 4 2 to the power 4 into 3 to the power 7 into 5 square. Right. Another way to write it as 5 into 2 to the power 6 into 3 to the power 7 into 5. Okay, another way to write it as 6 into something dot 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 dot. It keeps on going, right? Lastly, what will you get? The will go up to 2 to the power 6 into 3 to the power 7 into 5 square multiplied by 5 dot 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 dot, the last one into 1, right? So Aviraj, are you getting what are these? Tell me, what have I written? I have written all the factors of this number in the reverse format, right? How many factors are there of this number? But we have found it also, right? In part 1. Part 1, what answer you got? Number of factors.
Part 168.
168, right? And see, okay, so number of times I have written is 168, right?
Yes, sir.
This is 168. But the first way to write and the last way to write is same.
Yes, sir.
Second way to write and second last way to write is same.
Divided by 2 then.
Yes, so the number of ways will be equal to 168 divided by 2, which is 42.
Sorry, 4, yeah, sorry.
84.
4, yes, 84.
Right, tell me, is it clear?
Yes, sir.
Okay, try the next one. Number of ways n can be written as a product of two numbers which are relatively prime to each other. Try it out. Okay, Ronaldip, check your answer again. Okay, I think Nilanjan, you have written the answer. But I'm checking. Others also write your answers, everyone. Yes, Nilanjan, your answer is correct. Okay, so should I start? Tell me, everyone.
Just stop.
Yes, Ahid, your answer is correct. Okay, let us start. Okay. So we need to find out the number of ways in which n can be written as a product of two numbers which are relatively prime to each other. Okay. Pay attention. Okay. So over here, one way to write it as, see, let us say that there are three shops. One contains 2 to the power 6, another contains 3 to the power 7, means only the factors of 3. Another contains 5 square, means only the powers of 5. Okay, everyone. Try to understand, if you are taking one factor from over here, you have to actually take all of the factors. You cannot leave anything. If you leave even one thing, okay, over here, that means the other numbers will have a common factor. Like for example, you cannot select 2 to the power 5. If you select 2 to the power 5, then the other number that you have to select is 2 into 3 to the power 7 into 5 square. Because 1, 2 will be left out, that will be added over here, right? So if you are selecting anything from the first block, you have to select all of them. Are you getting, Aviraj? So over here, there are two things that can happen. Case 1, it can be written in the form of 1 into all three blocks, right? 1 into all three blocks. This is how many ways? One way, right? Tell me. Next, case 2, you can select one block. You can select one block and you can select two different blocks as B. Okay, understood? So in how many ways can you select one block and two blocks separately? Okay, see, either you will select 2 to the power 6, then the remaining two blocks will be selected in B, right? If you select 3 to the power 7, the remaining two blocks will be selected in B. If you select 5 square, then the remaining two blocks will be selected in B. So over here there are how many ways? 3 ways. So the number of ways will be equal to 3 plus 1, which is 4. Tell me. Avijay, is it clear?
So what will be plus 1 or 5?
Yes, sir.
HC plus 1 will be
One case in case 1.
oh,
Okay. Over here, three
Can I
cases.
explain the first case once?
First case, you select all of the three blocks as one number, and another number can be 1. 1 is also a factor of this number.
Oh, acha. Oh, yes. Yes.
Is it clear? Tell me, Trishita, Venkat, is it clear?
Yes.
Okay. Next. Okay, so till now, anyone having any doubt? Tell me.
No, sir.
No? Okay. If you don't have any doubt, let us do one last problem, everyone. Let us do one last problem, question number 6. Okay, next day, the LCM and HCF of two numbers. 168 and 12 respectively. LCM and HCF of two numbers are 168 and 12 respectively. Okay. If their difference is 60, find their sum. Okay, last problem. Okay, quickly solve. Did you people receive any assignment on number theory? Tell me. Did you people receive in the group? Hello.
I'm checking.
Check.
Yes, sir.
Oh,
Received.
received. In the next class, you people complete exercise 2.1. Okay, everyone. You people complete exercise 2.1. After 8:30, our class gets over. Okay, I'll be discussing few problems. Okay. Maybe I won't be able to discuss all the problems, but few problems I'll discuss from the assignment. Okay. And if you find any doubt, you can send me those problems also during the week. I'll solve it and send it to you. Is it clear to everyone? Abhijoy, Ahir, everyone got this?
Yes.
Okay. Apart from that, I'll be sending some homework also with you, just like I said. Okay. Okay, Ahir, check your answer again. Radik, there will be one more answer. Yes, Landon, can you simplify this? This can be further simplified. Yes, Abhijoy, right answer. Yes, correct. Yes, Ahir, there will be one more answer. Okay, everyone, let us start. LCM and HCF. Okay.
Sir,
Yes, tell me.
sir, the file you sent in the group for assignment, it's showing request access from email.
Yes, I'll find access. Okay.
Okay.
Means you request it. Okay, I'll give the access. Okay. Already few people have already requested for access. Okay, Abhijoy, did you receive?
Yes, sir.
Okay. Okay, it contains good problems. Okay, means some problems 2 markers, some problems are 3 markers, some problems are 5 markers also. Later on in exercise, I have another problem set. Okay, but that I'll give it a little bit later. Okay, but first of all, we have to target IOQM. Okay, qualification is important. Check it again. That's all. Is Lanjan right answer? Okay, LCM and HCF of two numbers are 168 and 12. Pay attention. So what is the LCM? Okay, so over here, can I say since HCF is 12, okay, let the numbers be 12x and 12y, right? Then can I say that 12x into 12y equal to 168 into 12, right? LCM into HCF equal to product of two numbers. So 12 is cancelled, and this 12 will go by. So xy is equal to 14. Also, their sum is given as 60. No, their difference is given as 60. So 12 into x minus y is equal to 60. That means x minus y is equal to 5. I've got x minus y. I've got xy. I want to find out. Okay, I want to find out x plus y. So x plus y whole square will be equal to x minus y whole square plus 2x. Right, tell me. This will be equal to 5 square plus 2 into xy is how much? 14. That will give us how much? 25 plus 28.
Plus 4xy plus x.
4x. You are correct. Okay. So how much will it give us? 25 plus 56, that is 81. So x plus y is equal to plus minus 9. So what is their sum? Therefore, the sum of the numbers 12 into x plus y, which is equal to 12 into plus minus 109, which is equal to plus minus 9, which is equal to plus minus 108. Okay.
So can I ask
Tell me.
about above. So the why did you multiply by 12 sir here?
Actually, I have taken the difference. The difference will be 12x minus 12y. So I took 12.
Oh, but you have the 12 above. Oh,
Okay. So Abhijay, Ahir, Niranjan, anyone having any doubt? Raudip, Tushar, Cut.
No, sir.
No, sir.
Okay. Remember what you have to do. Exercise 2.1, complete it. Okay. Every week you have to complete one exercise. Okay. Because some more assignments are going to come up. The sooner you are going to cover up. Okay. More and more assignments are going to come up. Okay. In these 3 months. Okay. Dates are already announced. You people know the dates of IOQMs. Dates are already announced. I'll be sending it in the group. Okay. So keep practicing. Thank you everyone and good night.
Thank you, sir.
Bye. Yes.
Sir, I have a few doubts. Will you be able to clear them in the doubt class?
Yes, sure. Doubts from which chapter?
Limit.
Sure. Okay.